Last time we looked at rational equations, which were equations with fractions. This time we're looking at radical equations, which are equations with square roots in them. And we're going to deal with them kind of in the same way. We got something new in an equation and we don't like it, so we're going to get rid of it. When we had rationals, we had division, and we got rid of it by multiplying. Here we've got square roots. We're going to get rid of them by squaring. We've got the 3x minus 4 square rooted is equal to 1. So I'm just going to take both sides of the equation. Right? When you do something to one side, you got to do it to the other too. And we're going to square them. Squaring a square root cancels that out, and we get 3x minus 4. 1 squared is 1. Now we've got an equation without square roots, right? One nice easy step, done. And then we can solve this simple linear by adding 4 to both sides to get 5 and then divide by 3 and we'll get 5/3. No problem. How about this one here? Got a square root, square it, square the other side, and we get 1 minus 2x. Right? The square and the square root cancel each other. 3 squared is 9. Subtract 1 from both sides, we get negative 2x is equal to 8. And then divide both sides by negative 2, and we get x is equal to negative 4. Easy enough. Here, we've got a step to do before we can square both sides. Right? Because we can't just square this and square that and square this. We need to square the whole side of the equation. So we want to do what we call isolate the radical. Get square root of z plus 2 equals, move that number over to the other side by subtracting, and we get 1. Okay, isolating the radical means getting the square root alone on one side and everything else on the other side, so we can do our square both sides step. And that'll give us z plus 2 on the left and 1 on the right. So z is going to equal what? Negative 1 there, I guess. Simple enough. Now, what makes this one belong in our chapter on quadratics is this guy here. First thing we need to do is isolate the radical, which gives us square root of x plus 4 on the left. And then we add 2 to both sides, so that's not going to combine like it did in the previous one, right? 4 minus 3 was equal to 1. But x minus 2, sorry, I wrote a plus. That's x minus 2 when we subtract 2 from both sides. That's not going to simplify. We can't combine those. So when we square both sides, we have to square that as a binomial. Square and square root cancel. We get our x plus 4. But on the other side, we're going to get, when we FOIL this, right? Remember, squaring a binomial is the same as multiplying it by itself. So you want to think multiply it by itself and then FOIL. X times x minus 2x minus another 2x. And then negative 2 times negative 2 is positive 4. Subtract 4 from both sides, will kill those off. Subtract x from both sides and get 0 equals x squared. What we're subtracting, so that's going to be minus 5x. And then that factors to be x times x minus 5. Set each of those equal to 0 and solve, and we get x is equal to 0 or 5. It's a little bit more work when we've got an x over on this side along with the number that we have to FOIL out. We get a quadratic that we then can solve by factoring. Just like with the radical or with the rational equations, we need to check to see if these answers actually work. If we plug a 0 in for x here, we would get the square root of 4, which is 2, plus 2 equals 0. 2 plus 2 is not equal to 0, so our 0 is not a solution of our equation. It's an extraneous solution, extraneous root, which means we didn't do anything wrong, just the process that we used gave us an answer that didn't work correctly. If we plug a 5 in, right, 5 plus 4 is 9, square root is 3, plus 2 is, yes, equal to 5. So we do get one solution there. And same thing as with the rationals. Sometimes one will work, sometimes both will work, sometimes neither will work. You just need to make sure you check them, and you do have to check them to make sure that they actually give you two equal sides in the original equation. Let's do one more like that. Square root of x plus 7 equals x plus 1. Our radical is isolated. It's alone on the left, so we can square both sides. Cancels the radical on the left. Boom, boom. And then we have to FOIL this out. X squared plus 2x plus 1. Subtract x from both sides. We'll get 0 over here. We're going to subtract 7 too. We'll get x squared plus 1x. If we subtract an x from both sides there. And if we subtract 7 from both sides, we get minus 6. This isn't a fact of like nature or reality. This is a fact of math textbooks. But when you get this radical, this should be one that factors fairly easily, because that's the only kind they're going to put in the problem set, and certainly the only kind I'm going to assign. So it's going to be 3 and 2. We need to have a positive 1 in the middle, so it's going to be x plus 3x minus 2, which means our solutions are negative 3 and positive 2. Okay, this is all old stuff. You should know that already. Go back and check. If I put a 2 in here, I get 2 plus 7 is 9. The square root of 9 is 3. 2 plus 1 is 3. I get 3's on both sides. That one works. Put in a negative 3. That would give me the square root of 4 here. Negative 3 plus 7 is 4. Square root is 2. If I put a negative 3 here, negative 3 plus 1 is negative 2. So I get a positive 2 on this side, a negative 2 on that side. Those are not the same, so the negative 3 doesn't work. So we have one solution that works here also, which is 2. And that is radical equations.